DataFinz is a powerful no-code data integration platform that connects to any source, ingests data in any format, and automates integration processes to accelerate business outcomes efficiently. DataFinz is a holistic no-code data integration platform that simplifies integration through intelligent pipelines, a wide range of connectors, and configurable workflows. It offers a built-in scheduler, job history, and logging capabilities. Designed by experienced data practitioners, it is highly secure, available both on the cloud and on-premises, and built to boost productivity with a consistent and intuitive user interface. DataFinz key functions include building a central data repository in minutes, enabling quick data sharing across various sources, modernizing databases with no code, and effortlessly validating data between disparate sources and systems. DataFinz connects diverse sources from APIs and cloud and on-premises databases to enterprise systems using intelligent pipelines like AI, API, ODS, and Modernize. With built-in tools like Swagger and Chat UI, it enables efficient integration, publishing, and automated data flows. DataFinz offers a powerful pipeline framework supporting API, AI, and data integration, along with ODS, API publishing, and database modernization. DataFinz add-ons enhance integration with features like metadata management, data validation, purging, data quality checks, rich visualizations, and a built-in scheduler for complete control. DataFinz connects with APIs, cloud and on-prem databases, data lakes, file storage, streaming platforms, LLMs, and enterprise systems, enabling broad and flexible integration. To create a REST API connection, the user can navigate to configuration in the DataFinz interface, click on Connections, New Connection, and specify the name, description if necessary, connection type, request, host, bearer token, post body, and other required parameters. A hint option is also provided to guide the users through each value. Here, the user can either mention the bearer token directly or configure a password using Azure Key Vault or AWS Secret Manager and call it in the CREDS connection. To create a Snowflake connection, users can again click on New Connection, specify the name, Snowflake as the connection type, and upon referring to the hint, provide the other required parameters. For Azure Data Lake Storage connection, following similar steps, a new connection can be created by specifying the name, Azure Data Lake Storage as the connection type, and other parameters with the help of the hint. DataFinz helps build a central data repository from various sources with rapid deployment, enabling enterprise-wide integration and a single source of truth. Having a central data repository streamlines access, enhances decision-making, and supports advanced analytics, AI, and machine learning. From business intelligence to disaster recovery, DataFinz optimizes data management for greater efficiency. DataFinz offers powerful features for streamlined data integration. Process multiple tables or files in a single pipeline and extract Delta records when needed. Enable versioning for changed records. Limit rows per extraction, and apply object-level filters for precise control. DataFinz built-in data quality options ensure accuracy and reliability. DataFinz is built on three key components. Connections link source and target systems for smooth data flow. The ODS pipeline processes and transforms data efficiently. With scheduling, automate data workflows for timely and consistent integration. Together, these components power a robust data management solution. DataFinz ODS pipeline integrates with both on-premises and cloud databases, as well as data lakes and file storage, enabling efficient and scalable data management. Using a single pipeline, multiple tables are efficiently connected, enabling data transformation from Microsoft SQL Server to Snowflake. For every changed record in the source, a new record is created in the target, with the current indicator highlighting the active record. This process is streamlined and simplified within the DataFinz ODS pipeline. The upcoming demo will showcase how it works in action. In DataFinz, users can create a new ODS pipeline by clicking on Create New ODS Pipeline. They then provide key details such as the pipeline name, source connection, target type, target connection, batch size, extract type, and setting the load type to version. Next, users select the appropriate object names and specify the extract and load types. DataFinz also offers upload and download options for spreadsheets, making it easier to manage multiple objects simultaneously. Users can apply filters as needed and select the required fields before finalizing the pipeline. If the incremental option is chosen in Step 2, Selecting the incremental column here is necessary. Once created, the corresponding tables are automatically generated in Snowflake with the appropriate data types. Additionally, users can download the DDL for the target directly from the interface. The next step is to execute the pipeline. DataFinz allows users to download logs and monitor the process in real time. It also provides statistical insights at both the overall process level and for each individual object. After execution, the updated records are visible in Snowflake. In this case, processing around 2 million records took just 1 minute for complete synchronization. To demonstrate data updates, an existing record is modified and a new record is added to the source table. Running the pipeline again reflects these changes in Snowflake, where the previous record's current indicator is updated to 0, while the newly inserted record is set to 1. When the newly updated record is modified again in the source and the process is rerun, a new row is added, updating the current indicator to 1 for the latest record while setting the previous entries to 0. Using a single pipeline, data from Microsoft SQL Server is efficiently synced and loaded into Snowflake across multiple tables. Optimized loading ensures structured data processing. The upcoming demo will showcase this in action. The process begins in the DataFinz interface, where the user navigates to the ODS pipeline. A new ODS pipeline is created by specifying key parameters, including the pipeline name, source connection, target type, target connection, extract type, and load type, which is set to sync. Next, the required objects are selected. For bulk object handling, the upload and download feature can be leveraged. Filters can be applied as needed, and relevant fields are selected. If the incremental option is chosen in Step 2, the incremental column must be enabled here. Once the pipeline is created, the corresponding tables are automatically generated in Snowflake with the appropriate data types. Running the pipeline initiates the synchronization process, updating records from the product table in Snowflake. By clicking Refresh, the user can verify the successful execution, and now, data from an additional table has also been loaded into Snowflake. To demonstrate data insertion and updates, an existing record is modified and a new record is added to the source table. Running the pipeline again reflects these changes in Snowflake by updating the modified record and inserting the new entry. Since the incremental option is enabled, only newly added or modified records since the last run are extracted. Using a single pipeline, multiple files from Azure Data Lake Storage are synced with Snowflake tables. Any changes in the source file automatically update the corresponding record in Snowflake, ensuring real-time data consistency. The upcoming demo will illustrate this process in action. The process begins in the DataFinz interface, where the user creates a new pipeline by specifying parameters such as the name, source connection, target type, target connection, extract type, and setting the load type to sync. In the next step, the required files are selected. When handling bulk objects, the upload and download feature can be leveraged. Users can also apply filters, select sheets or delimiters as needed. In the final step, the necessary fields are mapped, and if the incremental option is chosen in Step 2, selecting the incremental column here is essential. Once the pipeline is created, newly created tables appear in Snowflake, initially empty. Running the pipeline in DataFinz triggers data ingestion from the file in Azure Data Lake Storage, loading it into the Snowflake tables. When modifications are made to the source data and the pipeline is re-executed, the corresponding record in Snowflake gets updated. DataFinz enables data validation and quality checks, ensuring accurate and consistent records. This process detects and marks issues while transferring data from Microsoft SQL Server to Snowflake. The upcoming demo will showcase how it works. The user creates a new pipeline and specifies key parameters such as the pipeline name, source connection, target type, target connection, extract type, and load type. In the next step, the required source object names are selected. For bulk object handling, the upload and download feature can be utilized. Users can also apply filters if needed and choose the required fields in the Fields section. If the incremental option is chosen in Step 2, selecting the incremental column here is essential. In Step 5, data quality checks are configured. Users can enable null, duplicate, numeric checks or define custom rules. In this instance, a null check is applied to the user overview table for fields like first name, last name, and address. In the product overview table, A custom rule is set to flag records with a price below 500 as a warning. Once configured, the corresponding tables are automatically created in Snowflake. The next step is to run the process. After execution, the ODS pipeline report in DataFinz displays the data quality percentage based on the selected validation rules. Additionally, a new column in Snowflake highlights records that contain null values for first name, last name, and address, as well as those with a price below 500, ensuring visibility into data quality issues. DataFinz offers a powerful no-code API builder that enables users to create APIs from various data sources within seconds. It supports both OAuth 2.0 and basic authentication for secure access control, ensuring data protection. With serverless API deployment, users can seamlessly launch APIs without managing infrastructure. The platform also includes built-in rate limiting, allowing administrators to restrict the number of reads per user within a specified time frame. Additionally, DataFinz automates the generation of Swagger documentation, simplifying API management and integration for developers and users. DataFinz is built on 3 simple components that streamline data integration and API management. Connections enable integration with various data sources, including databases, files, and external APIs, ensuring smooth data flow. API Designer endpoints provide a no-code interface for creating and customizing APIs, allowing users to define endpoints, transformations, and security settings effortlessly. From various data sources, API Publisher has the ability to build APIs on top of tables, views, custom SQL, and stored procedures. DataFinz enables seamless no-code data retrieval by exposing tables as APIs supporting the GET method. This allows users to efficiently fetch records through API requests, ensuring quick, secure, and structured data access, all without writing a single line of code. In this demo, we'll walk through querying a table using GET with DataFinz. To begin, the user navigates to the API Publisher, selects the Designer option, chooses the relevant API name, object connection, and object name, and then creates a new endpoint, assigning it a meaningful name. After that, they select GET from the available API options. Next, the user chooses the required columns, and DataFinz suggests camel case field names for better readability. Filters can also be applied as needed. Once the endpoint is created, it's ready for validation. The next step is to add the endpoint to the API documentation and set up authentication for secure API access. The user navigates to the API Publisher, selects the documentation option, and provides the application name, authentication type, module name, and optional IP address before selecting the appropriate endpoint. Finally, the user can view API details in Swagger by clicking Authorize, entering credentials, and logging in. Upon execution, the user gains direct access to the table data, demonstrating just how simple and powerful DataFinz no-code API integration can be. DataFinz enables users to execute stored procedures as APIs using the POST method, allowing data operation with a no-code approach. This simplifies complex database operations by exposing stored procedures as API endpoints. In this demo, we'll walk through executing a stored procedure via API to update data using DataFinz. We have an example stored procedure that transfers an amount from one account to another. The user begins by navigating to the API Publisher, selecting the Designer option, API name, and choosing the relevant object connection and object type. Next, the user can create a new endpoint, give it a meaningful name, and select POST as the API method from the available options. The user then selects the required field names, filters, and the required input parameters to create an endpoint. Once the setup is complete, the endpoint is added to API documentation and authentication is configured for secure access. Finally, the API is validated and executed in Swagger. The stored procedure is then tested in Postman, where authorization is provided by specifying the source and destination account IDs for the transfer. Once executed, the user can confirm the successful transfer of the specified amount. DataFinz allows users to seamlessly expose Excel files as APIs using the GET method, providing no-code access and simplifying data retrieval. This eliminates complex configurations, enabling API-based access to Excel content with ease. In this demo, we'll walk through how DataFinz connects to cloud storage, selects an Excel file, and instantly exposes it as a REST API. The user begins by navigating to the API publisher, selecting the designer option, and choosing the API name to edit. They then enter the relevant object connection, type, and object name before creating a new endpoint with a meaningful name. Once done, they select Get from the available API options. Next, the user selects the required columns in the Fields section, while DataFinz automatically suggests camel case field names for better readability. Filters can also be applied as needed. Finally, the user can choose the necessary API parameters. Once the endpoint is created, it's ready for validation. The API is then tested in Postman, where upon execution, the user can instantly retrieve data from the Excel file. DataFinz simplifies data ingestion by allowing users to process and store JSON and XML data through a single endpoint. With its no-code approach, it effortlessly handles semi-structured data, transforming it into database tables without complex configurations. In this demo, we'll explore how DataFinz streamlines data integration and parsing through a single API. The user begins by navigating to API Publisher, selecting the designer option, and choosing the API name, appropriate object connection, and object type. Here, the endpoint is automatically created, eliminating manual configuration. Next, the endpoint is added to API documentation, and authentication is set up to ensure secure data access. Several parameters can be configured in this process. By reviewing the example values, users can identify locations where API data can be parsed or specify a connection name from DataFinz. Additionally, users can leverage other functionalities, such as adding new fields or setting up alerts for enhanced data management. Let's explore how to dynamically create a table in SQL Server while parsing JSON in Postman. Here, we have a sample JSON data containing nested arrays. When the user executes the request in Postman, a corresponding JSON table is automatically created in SQL Server. Similarly, by simply changing the file format and executing the request, an XML table is created. The newly created tables can then be viewed directly in SQL Server. DataFinz empowers users to combine multiple data sources into a single, unified API, simplifying data integration across different platforms. With its no-code approach, DataFinz combines various databases, file storage, and data lake for efficient querying and analysis. In this demo, we'll see how DataFinz integrates products data from PostgreSQL, orders data from Snowflake, and customer data from a Parquet file in Azure Data Lake Storage, all within a single API. The user begins by navigating to the API Publisher, selecting Designer option in the DataFinz interface, and configuring the API by specifying the name, object connection, and object type. In the next step, the user creates an endpoint by selecting Get from the available API options. Multiple sources can be added by clicking Add Source and configuring the object connections. Users can then specify objects, delimiters, aliases, and joins using a simple drop-down selection. The user can format the connection by clicking Share under each source and modify the object, field, condition, and connection as needed. Finally, the necessary field names, filters, and API parameters are defined to create the endpoint. Once created, the endpoint is added to API documentation, and authentication is set up for secure access. The API is then tested in Postman, where a single request retrieves combined data from all three sources. The user can now query products, orders, and customer details all through a single API with DataFinz. DataFinz API pipeline empowers data integration across multiple use cases with streamlined API modeling, response parsing, and request building. From supporting NoSQL to SQL migration, JSON ingestion, and real-time event processing to supporting AI and SaaS applications, DataFinz ensures reliable and scalable data workflows. DataFinz offers powerful features like automatic JSON/XML parsing, payload requests, nested array handling, and ERD diagram generation for streamlined data structuring. DataFinz enables the conversion of JSON data into an entity relationship diagram, transforming complex nested structures into well-organized relational entities for optimized querying and data management. The upcoming demo will demonstrate this process in detail. Here is a sample JSON data that will be parsed and converted into an entity relationship diagram. To achieve this, the user navigates to the DataFinz interface, selects API Pipeline, then Model, and chooses Create New Model. Then the user must specify a model name, add a description if needed, and select the required method. The user can choose from the provided options to upload file by selecting the correct file format in the input method and upload the file containing the sample data, or enter data manually using the model body option, or integrate via REST API by providing the appropriate connection name and select Generate to complete the new model configuration. The user can then click the download option to retrieve and view the generated entity relationship diagram. Comparing the sample JSON data and the ERD, the user can see all the entities, attributes, and relationships from the sample data in the diagram. API parsing from JSON to tables using DataFinz streamlines data conversion for structured analysis. The upcoming demo will illustrate this process. Here is a sample JSON data that will be parsed and transformed into structured tables. To achieve this, the user navigates to the DataFinz interface, selects API Pipeline, then API Parser, and chooses Create New API Parser. The user must specify an API parser name, add a description if needed, select the GetResponse method, and specify the input method as JSON. The user can choose model input, upload a file from the list of API options, or specify the connection by selecting the source connection name from the list. The target type is set as a table, and the user provides the target connection, target object, and selects whether schema changes should be enabled, which helps accommodate modifications done in source data, and finally set the load type. The user then selects source object names from the list and provide the corresponding target object names, maps relevant fields in each array in the next step to create the API parser. A corresponding SQL Server table is generated automatically with the defined columns. The user executes the API parser, parsing the JSON data into SQL Server tables. If the source JSON data is modified, re-executing the parser updates the modified columns and values in the target table. API parsing from XML to tables using DataFinz enables structured data transformation for better analysis. The upcoming demo will showcase this process. Here is a sample XML data that will be parsed and transformed into structured tables. To achieve this, the user creates a new API parser, specifies an API parser name, add a description if needed, select the GetResponse method, and specify the input method as XML. The user can choose the appropriate API option and select the source connection name from the list. The target type is set as table, and the user provides the target connection, target object, and selects whether schema changes should be enabled, which helps accommodate modifications done in source data. The user then selects source object names from the list and provides the corresponding target object names, maps relevant fields in each array, and creates the API parser. A corresponding SQL Server table is generated automatically with the defined columns. The user then executes the API parser, parsing the XML data into SQL Server tables. Database tables are transformed into JSON API payloads by extracting records from multiple tables and formatting the data into a structured JSON format, making it suitable for API-based data exchange, cloud storage, or application integration. Here's a demo to showcase this process in action in DataFinz. The user can navigate to the API pipeline in DataFinz, choose Model and create New Model option and provide the model name, description if necessary, method, and choose from the option to upload file or model body or REST API. By clicking on Generate, an entity relationship diagram gets created and can be viewed by clicking Download. Next, the user can navigate to the Integrate option in the DataFinz interface, click on Create New Pipeline, add the pipeline name, and make sure to specify the model name previously provided in the model configuration here. Then the user can include the other configuration like method, source connection, target connection, and call the target file name. In some cases, when the target system allows only one JSON object to be sent at once, it is necessary to specify the number in target process split rows. Otherwise, it can be mentioned as 0 and mention the request response connection and return object name followed by that if necessary. In the next step, the default object names will already be mentioned. The user can provide the corresponding override object names from the source table and then specify the necessary fields in step 3. The final step is to mention the YLT scripts in the script type if needed. After configuring the pipeline, upon execution, the JSON API payload gets created in Amazon S3. Data pipelines support key operations like data movement, YLT processes, real-time analytics, and machine learning model training. They also handle data replication, business intelligence, IoT processing, and data warehousing for efficient data management. DataFinz offers a powerful data pipeline with easy source-to-target mapping, API execution, and parsing. DataFinz supports data loading, streaming, metadata collection, and archival processes. It also integrates with platforms like Google Analytics, Google Merchant, and healthcare standards like HL7 and FHIR. DataFinz supports various data loading categories, including table-to-table, table-to-file, file-to-table, and file-to-file transfers. It also enables HubSpot data integration, compression, and decompression for efficient data management. Here's a demo that illustrates this process. To transfer data from table to table, the user navigates to Data Pipeline in DataFinz and clicks on Create New Integration, and proceeds to configure the integration by specifying the integration name, integration type as data load, table to table as subtype, source connection, source object name, target connection, target object name, and load type. After configuring the integration, the user can then run the process to load the data from source to target. API execution in DataFinz supports multiple methods, including get, patch, post, put, and delete, enabling efficient data retrieval, updates, creation, and removal across various applications. File Generator creates files from tables and other files, converting data into formats like CSV, JSON, Excel, and Parquet for various business needs. HL7 and FHIR processing includes parsing data into files and tables, as well as building healthcare data format from files and tables without the need for a single line of code. In the DataFinz interface, navigate to the data pipeline and select metadata. Click on Create New Metadata, then define the metadata name, source connection, target object name, metadata type as tables, and load type. Next, select the required object names. In the final step, map each metadata column to its respective target column. Once the configuration is complete, execute the process. Upon execution, the corresponding tables are created in the target, and the metadata of each object is stored in its respective columns, ensuring structured and efficient data management. Metadata collection for fields includes attributes like database name, schema name, table name, and comments. It also captures column details such as position, name, comment, primary key, and labels. To extract metadata from fields, the user can click on Create New Metadata and define the metadata name, source connection, target object name, metadata type as fields, and load type. Next, select the required object names. In the final step, map each metadata column to its respective target column. Once the configuration is complete, execute the process. Upon execution, the corresponding tables are created in the target, and the metadata of each object is stored in its respective columns. DataFinz data pipeline functions include Google Analytics for web analytics, Google Merchant for product catalog updates, and Reader for processing scanned documents. SQL Transformer cleans and aggregates data. Streaming leverages Kafka for real-time processing, and Remote Server executes scripts to handle external processes. DataFinz modernized pipeline streamlines database transformation by converting tables, views, and SQL while showcasing the dependencies. It enables seamless replication from legacy to modern databases with incremental or bulk options and sample data loading. Validation ensures data integrity by comparing tables, SQL, and views, skipping columns where needed, and detecting mismatches. With DataFinz, modernizing your data infrastructure becomes effortless and efficient. DataFinz simplifies database modernization with automatic DDL conversion, dependency diagrams for lineage and replication. Sync daily Delta records and validate legacy to modern data with ease, ensuring accuracy and efficiency. The process of converting SQL Server tables into DDL scripts and generating dependency diagrams is efficiently managed by DataFinz, ensuring accurate schema transformation and relationship mapping. This will be demonstrated in the upcoming demo. The user can navigate to modernize in the DataFinz interface, select Create New Convert, and specify the convert name, description if necessary, source connection, target connection, and table as convert type. In the next step, the user can choose the required source object name and map with the corresponding target object name. In the final step, make the required changes for each object if needed. Then, upon clicking on Download, the the user will get access to the respective DDL and their corresponding dependency diagrams. DataFinz transforms SQL Server views into well-structured DDL definitions while visualizing their interdependencies through detailed diagrams. The upcoming demo will walk through this capability. Here, the user can follow the similar process to create table by selecting Create New Convert and specifying the required parameters, including the convert name, description if necessary, source connection, target connection, view as convert type. Choose the required source object names in Step 2 and make the necessary changes for each object in the final step. After configuration, the user will be able to download and access the respective DDL and their corresponding dependency diagrams. SQL and DDL files are interpreted and converted into target format. The upcoming demo will demonstrate this process in action. To convert SQL files to their respective DDL, the user can again follow similar steps to create a new conversion, specifying the convert name, source, and target connections, SQL as convert type, along with the connection in which legacy SQL exists, and proceed to choose the required source object names in Step 2 and making the necessary changes for each object in Step 3. Finally, the user can download and gain access to the respective DDL. To convert DDL scripts to their respective DDL, the user can follow the previous steps and then download and access the DDL scripts converted into DDL target format. The replication process involves transferring SQL Server tables to Snowflake while preserving data integrity. This demonstration will highlight how records are efficiently copied and maintained. Here is the sample SQL Server data that can be replicated and copied into Snowflake tables. To achieve this, users can navigate to Modernize in the DataFinz interface, select Replicate, choose Create New Replicate, and specify replicate name, source connection, target connection, batch size, and other required parameters. There is also an option to choose if sample loading is required while replicating data with the sample records. This helps to identify errors if there are any in quick time. In the next step, the user can choose the required source object names, set the replicate type and their corresponding target object names. In Step 3, the user can apply filters to each source object name if needed, and in the final step, the necessary changes for each source fields can be made. The user can also make use of the upload and download options for efficient bulk object handling. After configuring the replication, the user can view the corresponding tables automatically created in Snowflake. By clicking on Download, the user will be able to view the generated DDL. Now the user can run the process. There is also an option to access the replicate report and view the execution progress. Upon execution, the data from SQL Server is replicated and copied into Snowflake tables. The data comparison process involves validating table records between legacy database and modernized database to ensure consistency. This demonstration will highlight how mismatches are detected and data quality is measured across both sources. Here are the two tables in PostgreSQL and Snowflake that are about to be compared. To achieve this, the user can navigate to Modernize, click on Validate in the DataFinz interface, select Create New Validate, configure the validate name, source connection, target connection, object type as table, and other required parameters. Next, the user can select the required object names and target object name accordingly. The upload and download option can be utilized for bulk object loading. In Step 3, filters can be applied if required, and in the final step, it is necessary to assign the primary key for each object and select the fields that are to be compared. After configuration is complete, the user can run the process. Upon execution, the user can access the Validate report where the insert count, data quality percentage, and mismatch count for each object can be viewed. If some of the mentioned columns are mismatched, the user can go to the target table and redefine the column definition, or, to compare all the other columns, the user can navigate to the configured connection in DataFinz, go to Step 4, and remove the mismatched column. Re-executing the process again gives the accurate data quality percentage that shows that all the columns from the two tables have matched. The comparison process checks data from SQL files between on-premises and cloud database. The upcoming demo shows how field-level differences and measures data quality based on mismatches across records are identified. Here is the sample SQL file from PostgreSQL and Snowflake that is to be compared. Both these files are uploaded in cloud storage. Now, to compare, the user can navigate to Modernize, click on Validate, choose Create New Validate and configure the validate name, source connection, target connection, SQL as object type, legacy folder, modernize folder, and other required parameters. Next, the user can select the required source object names and target object names accordingly. In Step 3, filters can be applied if required, and in the final step, it is necessary to assign the primary key for each object and select the fields that are to be compared. After configuration is complete, the user can run the process. Upon execution, the user can access the Validate report where the insert count, data quality percentage, and mismatch count for each object can be viewed. If the data quality percentage is not accurate, redefining the mismatched columns, re-uploading the SQL file, and re-executing the process brings the data quality percentage to 100, proving that all the columns from the two SQL files have matched. DataFinz features include selecting multiple tables or files, easy prompt engineering, automatic API generation with Swagger for LLMs, relationship detection through keys, and smooth usage in the DataFinz UI. DataFinz components include database and LLM connections, a prompt-driven AI pipeline to structure queries, and an LLM pipeline to generate intelligent insights. DataFinz empowers businesses with AI-driven insights by answering complex, domain-specific questions. From identifying top-performing products to analyzing shipment delays or healthcare trends, it helps decision-makers quickly extract value from their data. Prompt build requires selecting tables or file lists for analysis. DataFinz identifies primary and referential keys in tables, establishing relationships when defined. Questions paired with SQL answers train the AI agent, enabling translation of natural language into accurate SQL queries. The LLM configuration involves setting model type, alongside API authentication options like basic, bearer, or no auth for service integration. The SQL Server tables form the foundation for generating both relationship diagrams and table properties. Once a prompt and LLM are integrated, the users can pose questions and receive answers directly from the data. DataFinz UI processes a user question, generates SQL queries, retrieves the data, and presents automated insights. DataFinz APIs enable interaction between the LLM and backend systems. Dedicated endpoints handle text-to-SQL conversion, SQL execution, and combined data retrieval, forming the core of the insight generation workflow. A natural language question is processed through the DataFinz API, which returns the generated SQL, the resulting data, and a summarized insight, illustrating the end-to-end flow from query to analysis. The upcoming demo will show this process in action. The user begins by navigating to AI pipeline in DataFinz and creates a new prompt by configuring the prompt name and connection, and proceed to choose the required source object name in Step 2. In the final step, DataFinz builds sample prompts by default. Users can add more questions if necessary by clicking on Add Question. During this step, DataFinz builds the relationship between the tables if it's already defined in the table definition. After configuring the prompt, users can next choose LLM, click on Create LLM Configuration, and specify the LLM name, prompt connection, and OpenAI as the LLM connection. Then the user can specify the relevant authentication type and configure the authentication by setting a username and password. Now another LLM configuration can be created by specifying DeepSeek as the LLM connection and specifying the authentication type. To execute agent, there are two options. One is to execute the agent in DataFinz. After entering the credentials created while configuring the authentication type, the user can mention the question for which DataFinz generates SQL queries, retrieves the data, and an analysis of the dataset. Another option is to authorize the agent in Swagger or Postman, or calling it from Python or Java, or from any other programming language. DataFinz data visualization enables exploration of objects by data type, cardinality, and nullability. Field-level insights include detailed profiles, word clouds, and multiple charts for faster and smarter data understanding. Object analysis provides insights into the number of rows along with fields, identifies data types, evaluates cardinality by highlighting the top 5 and bottom 5, and examines nullability by surfacing the top 5 and bottom 5 fields with missing values. The upcoming demo will showcase this process. The user can begin by navigating to data visualization within the DataFinz interface. Click on Object, create new object visualization, and specify the name, an optional description, connection, object type, and object name. Upon clicking Generate, users can view the object visualization reports, which include object details, data type report, cardinality reports with the top 5 and bottom 5 fields, and nullability reports with the top 5 and bottom 5 fields within the DataFinz interface. Field analysis involves visualizing data through multiple chart types, enabling aggregation options, defining KPI levels, and allowing the use of optional filters to refine insights. Charts are tailored based on data types with options like bar, pie, histogram, box plots, and more. The user can navigate to data visualization in the DataFinz interface, click on Field, create new field visualization, and specify the name, data profile, bar as the chart type and field name. For the aggregate, if sum is selected, it is necessary to specify the KPI field name. If count is selected as the aggregate, then it is not necessary to mention the KPI field name. By clicking on Generate, the bar chart gets created. Now the user can again click on Create New Field Visualization. Enter the parameters like name, data profile, box plot as the chart type, and field name. By clicking on Generate, the created box plot can be viewed. The same process follows for word cloud chart creation, where a new field visualization can be created by mentioning word cloud as the chart type along with the required field name. By clicking on Generate, the requested word cloud chart gets created. DataFinz components include setting the run mode and execution for automated tasks, configuring recurring time for regular schedules, selecting DataFinz pipelines for data processing, and enabling email alerts to notify you on task updates or issues. DataFinz Scheduler offers 2 run modes, recurring for repeated tasks or run only once for a one-time task. For execution, tasks can be set to run sequentially, one by one, or in parallel, simultaneously. DataFinz Schedule Builder provides time options such as minutes, hourly, daily, weekly, monthly, and yearly. It also supports cron expressions and allows setting a start and end date for the schedule. To build a scheduler, users can navigate to the configuration in the DataFinz interface, click on Scheduler, select Create New Schedule, and specify the schedule name, a description if needed, and the required run mode and method of execution. If Run Only Once has been set as the run mode, it is necessary to mention the single-time run. If recurring is chosen, the user can build the scheduler by specifying the start date and end date or other parameters like minutes, hourly, daily, weekly, monthly, and yearly as needed. After specifying the required time option, the user can save, click on Next, pick the necessary filters, and configure the stop on error if needed. The final step is to enable email alerts. Here, the user can mention what the alert is for and the email address. Users can add more emails if necessary. Once set up, the scheduler can be disabled or enabled at any time based on operational needs.